Okay, before I resume our lecture on inheritance, which today my main focus is introduce the concept called virtual function, or the other programming language concept called polymorphism, which we'll talk about that. But I just want to catch up a little bit on your homework assignment number 2. Which I found somewhat interesting about the situation I'm currently in. As I mentioned, I have been sick for the past couple of days. Of course, the first thing I came to my mind is, oh, maybe I got COVID again. So that's why I'm actually thinking, but why is this related to homework assignment number 2? I start to introduce some idea toward your final project, which I actually realized your homework assignment number 2 is a really good tool for us to tracking about your risk or your exposure to COVID on campus. So let me actually say, assuming each one of us is keep tracking where we are at which location. So you have a GPS location, you have a time. So assuming all of us on UC Davis campus, we actually have that record. You can represent as JSON or whatever way you want to represent. And so now there is a one person who actually, that person's name is Felix, who assuming he were detected to be COVID positive as now. So you probably know if you got COVID right now, you probably already got it and become contagious for the past 2 days or even 3 days and things like that. So what I can do is that I pulled out the record about where I have been for the past 2 or 3 days with the timestamp and for the GPS location. And I kind of strip away my identity because we have to consider the privacy. So I actually submit a JSON to a server on campus saying that I have been tested positive and this has been all the location and time where I have been for the past 2 or 3 days. So this will be uploaded somewhere on campus, which is, in my mind, it will be local server. So there's nobody, it's like the server over here, nobody else can actually access except the UC Davis community member. So now each of you actually will periodically check, and you will also submit your own record about, okay, I should actually take it back. So the server will receive a report on COVID positive with the past maybe 48 hours window about where this potential patient has been for this 48 hours. And what you should be doing is that you keep your record because your record represents your privacy. So don't upload your record, but instead download that particular anonymous GPS location and time regarding a particular room, say this particular classroom, which at that time you were there. So you kind of can match how likely you have been in that location. And furthermore, you could do this or you don't have to do this. Furthermore, you can do is that I can test COVID myself for one of you and realize you got positive too, and then you realize you are actually being contagious because you came to this room. And that will kind of propagate in such that we can have a very good information regarding who should actually do a test and who should be quarantined and what is the pattern of the spread about a contagious disease and things like that. So if you think about that, it's interesting. The information is definitely there with your GPS location, with your time. And to me, the one of the main challenge is how do you do all this with privacy being guarded? Meaning that you don't have to expose too much about your own information. So I think that's kind of interesting, realistic, related to your homework assignment number 2. So just share with you that that's a potential extension you might consider to work on that as part of your final project. Okay. All right. So that was that. So now let's go back to inheritance. So far we have been talking about the basic single inheritance, which is a base class, and the derived class is a relationship. What we have been doing, okay. What we have been doing is asking a question looks like this. So because we have a hierarchy of classes, and therefore the issue is for each of the class, we might have the member function that's being defined with the same function signature, but they represent in different location in the inheritance hierarchy. Yes. Yes, it's being recorded. Yeah. Thank you for asking. So we talk about the concept in C++. I mean, from the programming language perspective, it will check the data type about the object, which is the class. And based on the class, it will determine whether it should call exactly which version of the member function that's actually share the same function signature. So in this particular case, I actually create two objects, object 1 and object 2. So object 1 was created with my base, which is the base class. I create an object 1, and then I actually create another object called derive, which is create based on the child class. So the natural question to ask is when you call object 1.foo and object 2.foo, which version of the foo will be invoked in this case? So that's basically you try to, based on the class of the object, to determine that which version of the function, member function, should be invoked. And then we teach another trick, which is quite interesting. This trick is unique to C and C++ programmer, called casting. So when you add a casting, you convert the data type of a variable, of a class, or object to another class. So in this case, you can see that object 2 is belong to the class my derive. But then I can do a casting in front of that, my base, and such that I change the type of the object 2 to the base. And then when I call foo, then it will actually invoke the base version. So essentially, we're using casting to manipulate, to decide, to control exactly which function you like to call. So this is a very essential when you deal with inheritance. So this is a bit tricky if you never do this kind of inheritance related programming, is that when you call a function against a particular object, you're really against not just a single class, you're against a hierarchy of a variety of class. And then you use the casting so far to actually determine, to control which function you want to use. So this is this is the result. If you make this call, you can see that I have a two version. One is the foo associated with my base, and another foo is associated with my derive. So when you do object 1.foo, it goes to the base. Object 2.foo, it goes to the derive. But then you casting object 2 into the parent class. Then essentially when you do call foo, it will go to the parent. Okay, so your casting really change the semantics. about the function that you thought you're calling. Okay, so this is a trick. And furthermore, we actually show the example. Sometimes you can cast up, means that you change the data type such that it go to the a parent class or ancestor class. But you sometimes, not always, but sometimes you can also do cast down. So because you think about that, I have an object which belong to one of the base class, one of the derived class, and I cast up. Cast up means that okay. By the way, there is a two kind of cast up. One kind of cast up is actually copy. I actually make a copy of the parent portion of the derived object. So I really only have the parent, but sometimes in this case, this cast is by reference. So when I do this cast by reference, when you see reference in C++, it's essentially like a pointer or address, but it's just syntactically, it looks like it's a regular object. It doesn't have this pointer notation, but it is really a pointer internally. So when you do this kind of casting, the original form of the object, which is the derived class of the object, that portion is still there. So in that case, you want to cast down because you want to convert the behavior to the parent, but then you want to move down. So you can actually do cast up and cast down in the hierarchy. Okay, that's kind of what we have been talking about before. I forgot when we talk about that, maybe 2 lectures ago or 3 lectures ago. Okay, so now today we're going to introduce something different called virtual function. So virtual function is yet another way for us to control which function you want to use when you want to call. And by the way, virtual function in my mind is very useful. When I write program, I use a lot of virtual function. But first, let's make a definition about what is a virtual function. So number one, yes.
You might have already said this, but what is like an example where we have to cast objects to as its base class instead of just using the base to call a function?
Okay, so good question. Let me give you a real world scenario. Assuming we have a hierarchy, let's now give an example. Assuming the base is a person. It's a person. But then the derived is a student. So you have a class student is a class person. Okay. So now I want to keep an array about all the GPS location in an array. Okay. In C++, by the way, we usually call a vector, but in C, we can still call it an array. So I keep an array of the GPS location associated with each person. So this is the array of a person. I mean, think about that. Some of my objects in this community are person, some of the objects my teacher, some of the objects are student, but the common denominator is person. So what I will do is I will convert all the student, teacher, employee, convert by casting up with a reference to person. So then the array is just array of person because I want to check the COVID situation. It doesn't matter. Okay, so now I have that. So in my array, I have a lot of person. Okay, now it's tricky. I realized one of the student is actually exposed to actually I don't know it's a person. I don't know it's a student. It's just a person, right? So he has been exposed to COVID. Now I want to contact him. So now when I pull that out from the array, it is a person object, and I have no information to know whether this is a student, because with a student versus faculty, I might have to do some like different procedure. So in that case, if there is a student protocol that I need to apply when the student get attracted to COVID, then I need to do either I should cast down to convert it back to a student object so I can deal with using the student protocol, or I have to do something called virtual function, which I'm going to talk about today. Okay. Exactly. So that's why when you cast up, if you use a reference or pointer, because the content is still there. So if I remove that ampersand, it's a copy, means that I only copy the base, the data related to the base. So everything related to student, they're gone. Okay. Is there a question in the back? Okay, good question. Okay. Any other question regarding this slide? So I just want to tell you, there is when you have a class hierarchy, depending on the application, and sometimes you really want to cast up to certain higher level abstraction so you can cover a lot of cases. But sometimes you need to cast down because I have some specific I need to work on for that particular child class. Okay, that's the kind of beauty and power to do object-oriented programming. Okay. Okay, now let's actually talk about virtual function, which I consider this is the hardest topic in the whole C++. This is essentially equivalent to pointer in C. Okay. The basic semantic is not so bad. We're first going through the easier part, which is the language part. But later, not today, but next week, I will talk about a lot of hold on. Yeah. The computer science department chair just called me during my lecture. Okay, I turn off the phone. I'll talk to him later. Sorry about that. So first, let's talk about the easier part about the virtual function. First, declaration. How do I actually specify that this function is a virtual function? So when you have a member function foo, you actually add the keyword virtual in front of that. So let's just see an example. If you remember, hold on, I want to go here. So this is the master directory. If you go to, say, gps.h, so this is a definition of the GPS class. Let me make it a little bit bigger. You can see I have a bunch of things. I have an attribute, as we know, latitude, longitude. I have a constructor. I have a member function called get latitude, get longitude, distance, and then I have operator overloading, which is here equal. But then I have a two function. One is called dump to JSON. One is called JSON to object. And don't worry about this two function yet. We're not there yet, which is another subject for learn. But can you see that I put a virtual keyword here? So when you add a keyword virtual in front of a function signature declaration, and that function is considered a virtual function. So you declare that particular function is what we call virtual function. By the way, you only declare when you have a class definition like here. So why I said that, I just want to make sure you understand this. But if you go to gps.cpp, and if I say dump to JSON, you see that here is the implementation of that function I just declare in the .h file. And over here, you see that I just basically put together the function signature for that member function implementation, but without saying that, without using the keyword virtual. So virtual only need to be putting in that class definition file. Okay. So that's the way to specify. Okay, so I'm just telling you syntactically, how do you make a member function become virtual function? Okay, now let's actually go back. Now this one. Okay, okay. So now we have the foo function. Now in this example is a virtual, and I still have object one and object two, exactly the same 5 lines of code. I still have this 5 lines of code. Okay. Remember, if it's not virtual, the result looks like this. Okay, if it's not virtual, the first call to the foo and the third call to the foo, they both go to the base. But then the second call is going to the derive. Okay, that's just remember, that's the result. If the function was not virtual. Okay, now let's actually take a look. The same code. Take a look at this. Now the first two are still the same. If you have object one, object two, they're still the same. But object three, sorry, the third line, which is a casting of object two, when you call that foo, it's actually still go to the derive instead of go to okay. So first, I'm just telling you, if you write a program looks like this is going to be the behavior of the program. Number one. Okay, I hope you just accept that as it's a feature called virtual function. What based on this result contrast to the previous result, what do you see the difference? What do you see the unique uniqueness about virtual function? What do you think the difference between virtual function and non-virtual function? I should probably just ask you this. What do you see that virtual function can do for us? Anybody? just make a guess. That's okay. Yes. It still has a derived class. So one of the thing is that thank you. So one of the thing, if you notice, I think most of you probably already noticed, you just maybe it's the way I asked the question is poorly formed. So essentially you will observe is that casting is not make any difference for which function you're going to call. So essentially when you have a virtual function, is insensitive to whatever casting you want to go. It will always go to whatever version it is. Okay, agree with that? Okay, so the only difference is the third case. And the only thing, the third case is different from the second case is I provide casting. With this, with casting, I'm actually changing the functions to the base class. But with virtual, it actually call to the derive. Okay, so that just keep that in mind. So it means that casting is not doing anything. Okay. Okay, everybody agree? Everybody good about that concept? All right. So now let's actually try to interpret what do we mean by casting doesn't make any impact to decide whatever function you want to call. What does that mean? Okay, this is probably most of you first time look at this, so I'm going to directly hit to the point. So is a virtual function, if it's non-virtual function, for us to decide which function to call is purely driven by what? by the data type, by the class or the data type about the object. Okay, remember that without virtual function, I will decide which one to call is actually depending on what is the data type, right? Is that everybody agree? Okay, that's pretty straightforward from the basic member function. Okay, so let me ask you another question. Does compiler, when the compiler look at this program, can the compiler determine what is the exact data type of the object before you call the member function? Can the compiler decide on that? Oh, okay, just let you know, maybe again, is the way I ask question is poorly, and just let you know the answer is a yes, compiler no. If you look at this, object 2, right? The compiler need to see where object 2 was declared, which object 2 was declared as my derived. So the compiler know what's the data type of the object. And based on the data type of the object, the compiler will choose the version of the foo function that's associated with my derived. And the third line, compiler still know because compiler also know casting. I mean, by the way, casting is the information the programmer tell the compiler that I want the compiler to treat the whole thing within that pair of parentheses as one object. So essentially, casting means you change the data type. When the compiler look at the third line, the compiler actually look at that and determine that, hey, wait a minute, that is actually going to suppose, because you do that casting, is going to be the base. That's why it calls my base. So in regular member function, it's compiler's job to determine. By the way, compiler always look at the data type. Compiler need to look at the data type and the variable, and then from there, we will know whether you're doing correct thing or not. Because if you actually declare, the compiler realize that you declare this as this type, but you try to use it differently, the compiler will give you syntax error or at least give you some warning. So in this case, it's compiler's job to decide. Okay, so now this is the exciting part to make a virtual function very hard. Is that when you declare as a virtual function, the compiler doesn't know anything. The compiler intentionally, okay, it's a design, meaning that the compiler no longer can determine whether which object that, well, which function I should call. Okay, just make it simple. When you have a virtual function, it's no longer compiler's business. That's how the way I will put it. Meaning that when you have a virtual function, it must be something else to determine which function you need to call, but it's not compiler. That is a very important concept. So meaning that when you declare something as a virtual function, you really don't know. You really don't know that exactly at compiler time. It won't know. Okay. Okay. That might sound strange to you. You say, well, how come you have a programming language which compiler doesn't know the exact function to call? That's why virtual function is interesting. Because instead of having the compiler, I actually rely on runtime. So let me tell you the 3 stages about your program. The first stage is compiling. The second phase is linking. Okay, compiler linking, they're usually together, and the G++ program is doing both the compiling and the linking. And after you generate the executable, you're going to run that executable, and that's called runtime. So one is compiling time, one is the runtime. So essentially what we're saying is that, okay, this exactly which function to call, if it is a virtual function, it's not going to be determined by compiler time, linking time, it will be determined by the runtime. Until runtime, you won't know that. So that might sound kind of strange if you've never done this kind of programming before, but it's kind of exciting because, wow, I actually can create some language that I can do certain thing at the runtime instead of kind of pre-wired, predetermined what I need to do at the time when you write the language. It will not, you actually have no idea until you run the program about exactly the behavior of the program. That's why sometimes we use the word polymorphism. Polymorphism means that this particular program or this particular object has multiple behavior. And the thing is that, unfortunately, a lot of this case in real world is non-deterministic. And I don't know exactly which function will get called until much later. Okay, so having said that, a lot of things I just said is kind of like a metaphor or whatever way you put it. But now I'm going to tell you, how does the runtime decide that I'm going to call this function? So I'm going to give you the rule. Let's see if you can understand this rule better. Okay, so here's a virtual function. Let me actually see, do I have a sorry. Okay, so I will use this as a contrast. So I have a two function. I can declare as a regular function. I can declare as a virtual function. So if it's a regular function, so at the time you make the call, at the time you make that function call, I'm actually going to look at the class, which class is associated with the object, and then decide which function to call. So this one, because it's at the time of the call, is actually under the control of the compiler. At the time when you call it, that means in your program, I know precisely I can determine the class time. Okay, but now this is the definition for the virtual function. So the virtual function basically say, I still want to decide what is the class of that particular call. But that particular call, sorry, that particular class, when I want to determine is not at the time of the call, but instead at the time of the creation of that object. Okay, so now this is the first time you probably heard about that. So let me tell you, what do I mean by object creation? Assuming you have a very big program across 255 files, the source code. So it's actually the program, the function program number one, you actually create that object. You create an object about one of the 255 files, but then you wait for a long time. Okay, your program is really running long, but after like 400 days, and suddenly at the other file, you try to call that particular function based on that object you create 400 days ago. So now this is the tricky part, that when I decide which function to call, I'm actually going to look at 400 days ago. What was your class membership? So essentially, I'm looking at the time it was created, which was 400 days ago, and then look at what was the class. Was the class derived by, created by base or created by derived? Then I would determine which function to call. So it's at the time of the creation. Okay, so let me go through the example, then I come back to say why is it. So for example, I'm on my base object 2, right? So what in this 5 lines of code, when did this object created? When did the line number 2, right? The second line was the code, it was created. So I kind of write the code looks like this. It looks like this 5 lines of code is together, but in reality, the first 2 lines separate by the next 3 lines, by 400 days, assuming your program run that long, okay? So I need to decide whether that particular object was created as my derive. So regardless how you casting it, I need to, wait a minute, what happened? Okay, still working. Okay, good. I didn't break too much stuff today. Okay, so therefore, if you casting doesn't matter because I always care is at the time of the creation, what kind of class type that you have. Okay, so let's actually go back to the example. Okay, I'm going to give you this example and then I will let you to ask question. I'm going to go slow here, okay, because it is a bit abstract of the program about the virtual function. So at the beginning of the class, we say we have an array of persons, which is the derived class are student, faculty, and employee. But the base class is a person. And when I store each of the record about your GPS location for the purpose about tracking the COVID cases, that I actually store every single object into that array of persons. So in some sense, every single object that I store in that array has been casting up from student to person, from teacher to person, or from a staff member to person. Okay, so inside the array is all about person. The object is a person. Okay, but this student object must be created 400 days ago. Probably, okay, 400 days ago, when you first joined, I created an object called a student. And the thing is that the class type of that creation 400 days ago is a student. That was already associated with the object in some way, which I will tell you more about implementation of the virtual function. That gets really complicated, okay? So by the way, you need to learn two things. One thing is you learn what is a virtual function, how to write a program using this feature. But the other part is, as a slightly more advanced topic, you want to see that how virtual function is implemented such that you know it has to be determined by runtime. It cannot be determined by the compiler time. That's the about like one level down from the service of the language, which is important concept for you to understand. So okay, let's go back to here. So I pulled out a person object from this array of UC Davis, and I want to notify this person regarding his vulnerability to COVID. So now, but when at that time, and whenever compiler compiling this piece of code, we look at that, it's just a person. It's just a person. And the compiler doesn't really know whether this object was created as a student or teacher or staff. He doesn't know. The compiler lost that information. Let me put it that way. So the virtual function now can actually, at runtime, determine that, wait a minute, this object was actually created as a student 400 days ago. And therefore, when I want to call a function like a notify, it will at runtime decide, okay, I need to call this particular function. And then basically it will call the notification protocol for a UC Davis student. Okay, so that's the way that the virtual function will work. So let me summarize. So virtual function essentially is saying that the system, runtime system, will have a way to keep tracking about what was the class type that this object was created. I don't know when, maybe 5 seconds ago, maybe 500 days ago, I don't know when. But the system will actually remember that. So when you want to call this particular function at runtime, the system will retrieve that information and make the right call. And whenever you do casting or not, whatever, because you convert it to from student to person, it won't affect the calling target that you try to invoke here. Okay. Any question? I see a lot of. Is that confusing, this concept? Okay, don't worry. I'll make sure that homework assignment number 3, you got some chances to work on this. I mean, it's just writing a few programs, then you start to getting it. Okay. Any question? Okay, now let's look at some source code. Okay, look at some source code to do that. So I'm going to I'm using this piece of code to talk about. I'm going to use MT3, which is the midterm number 3. No, not here. Yeah, here. No, this is MT3. Yeah, midterm number 3. Okay, in midterm number 3, let me remind you with the inheritance hierarchy, which is where is that file? I'm kind of embarrassed. Wait a minute. No, I know. I will just directly go to the midterm. I actually save it somewhere. Okay, I will use the 36b. Okay, first let's take a look at this inheritance hierarchy. Okay, this is a midterm number 3 last quarter. No, 2 quarters ago. We're looking at this inheritance hierarchy, which has the base class is thing or MT3 thing. And then it has the derived class. The first label derived class is locatable. The second derived class is called holdable. Okay, so the thing is just a generic thing that you can use for anything. That's a base class. And locatable means that it has a GPS. It has a GPS feature. And I hope the microphone is locatable. Somehow it will help me to avoid being tricked by the corner of this table. This is probably the 3rd time or 4th time. Okay, you can hear me, right? All right, I'm sorry about that. Okay, I will stay away from this table. All right. Locatable is just to have a GPS location. Okay, so now you can track your phone, your maybe it's a pacemaker in your heart and things like that. And then there is the other one is called holdable. Holdable means that this item can be possessed by a particular person. For example, a smartphone is holdable because it both have a GPS location and you can actually hold it. Okay, so that's the class hierarchy. MT3 thing, locatable, holdable. Okay, that's an example of 3-level tree of the hierarchy. All right, so if you look at the function, I have a one virtual function is called dump to JSON. Called dump to JSON. So now I'm going to tell you a little bit about what is dump to JSON. You will see this a lot. It's a very useful tool for us to understand, to see the content of the object. So let me first tell you what is dump to JSON. So one of the things we realized even at the very beginning of the object-oriented program, we realized sometimes, yeah, you have all this idea for class, you have all this idea for whatever inheritance, but there's a one unique feature we must have is called dump. Dump essentially is saying that you have object, I want to actually print out everything that's within the object. I mean, for example, if you have a health record represent yourself, then essentially I want to dump all my health content. So I will be able to do some kind of analysis. So dump is, you can think about dump is a printout, but dump is more general than printout. Dump is essentially, I just want to carry out every single piece of information from the same object. So I will be able to either let human read it or let other program be able to process that. Okay, so that is what we call the concept called dump. So you can imagine I might have dump for MT3 thing. I might have dump for locatable. I might have dump for holdable. So when I try to do dump, and obviously when I have a dump function, that the way I dump the MT3 thing, it might be a little bit different when I dump locatable and the holdable. So I have a three different versions of the function. One is a dump for holdable object, one is dump for locatable, one is dump for MT3. And then we talk about another concept called dump to JSON. So the difference between dump and dump to JSON is that the traditional implementation of dump is just printf. Okay, we just print out all the information for human readable. But that is disadvantage if you want to use this information to do something else. So instead, dump to JSON is essentially we're using the JSON as like your printer, like the printing of the paper. So instead of printing on a piece of paper or print some character in front of your terminal, you actually print it into a JSON. So that JSON, of course, you can print it out later using to style string, using cout, you can actually print it, but you also have that JSON representation. You can do a lot of other things, such as reusing, using this dump information to do your other type of application, okay? All right, so now we have a hierarchy. We have a single member function called dump to JSON. And we have three virtual functions. It's the same virtual function with the same function signature, but it's actually being associated with three different classes. Okay, and remember, virtual function, you have the keyword virtual, and the function name is dump to JSON, and this function takes no argument, and then the return of the dump to JSON is a object which is a JSON column value. Okay, so that's it. It will return a JSON object as the word for dump to JSON. Okay, I do want to say that in this midterm, I use the function signature was JSON column value. I believe later I actually change everything to pointer. So let me just make sure when you don't get confused when you look at the master directory. If you go to master directory, if you look at here, you see that this line, virtual, and then the return is JSON star. Okay, so the midterm 3 was earlier development of the code. But at some time, I think last November and last December, I kind of rewrote every single line of code. And I forgot exactly the reason, but at that time I realized if I declare as a pointer, is easier, much easier for me to handle. It's probably for exceptional handling. I feel that having a JSON value pointer is probably more convenient for me. Okay, so just to let you know, if you look at the master directory, the function signature of dump to JSON is different. Over here is actually a pointer to the JSON object with dump to JSON. But your MT3 thing, which I'm trying to cover right now, it is, let me go to Emacs minus locatable, say locatable.h. You can see that over here when I did the midterm number 3, it was actually declared at this. Okay, so you have to watch very carefully about what is exactly the function signature do whatever you want. Okay. All right. So so now let's actually look at each of the function. Okay, to look at locatable, holdable, and the MT3 thing and see what the virtual function is actually doing in their lifetime. So let's actually first look at MT3 thing. So MT3 thing, I have this virtual function called virtual whatever, dump to JSON. Okay, you actually saw that. So now let's look at the implementation. Okay, here is the dump to JSON. Top is the implementation. Down here is a declaration for a virtual function dump to JSON. So let's actually take a look what I did over there. So if you look at this, the function is extremely simple because what I want to do is try to dump the internal data within an object. That's what dump is supposed to do. It's going to do everything you want to dump. For example, if you do a Unix environment, there is a program, not program, but there is a phenomena when you have a segmentation fault, you actually see a program, a huge file was generated called core. That's called core dump. So core dump is they actually dump everything in your execution of the program, the information, so you can actually debug a problem such as segmentation fault. Okay. So over here, because I only have one attribute called sequence number. So you see that the way I do it is I create a JSON object result. Okay. And then I check if this to the sequence number is not equal to 0. Have I ever explained the syntax using this? Okay, all right, I did. Okay, if you have a question, it's just this is just this particular object, this, yeah, I don't know how to, it's like a self in Python. Okay, I check whether that sequence number, if it's equal to 0, but the sequence number, if it's never set, is default to be 0. If you set the sequence number, you see that I'm doing result sequence number is equal to this sequence, okay? Whatever the sequence number I have. So this essentially create a JSON object that's actually only have that sequence number. Okay, so that is the MT3 version of dump to JSON. It's only deal with sequence number. Okay, any question with this few lines of code? This is a JSON program. Okay, try to create a JSON object with that key called sequence space number. Okay, let's actually take a look at locatable. So again, locatable is inheriting from MT3 thing. It has a GPS location, just let you know. This is not a GPS object. Instead, it's the GPS DD star, means location is a pointer to a location object. Okay, I'll later explain why sometimes I use without star, sometimes I use a star. It's probably just try to save some memory or save some copy. And then I have locatable, I have dump to JSON. Okay, now let's take a look at the implementation of the dump to JSON in locatable. Okay, here's the dump to JSON. Okay, I want you to take a look at this code. Before I explain, I want you to kind of see if you can understand that's what's going on with this 1, 2, 3, 4, 5 lines of code, 6 lines of code. This is a little bit more complicated than the previous piece. Okay, let's take a look at this code. Okay. So what is dump to JSON for locatable? It's dumping an object, but it's supposed to dump both the right portion of the data, but it also supposed to dump the parent version of the portion as well. So I need to dump both the information contained in the MT3 thing, which is the base class, and also I need to dump the things in my current class, which is locatable. So the first line is actually dumping the parent. So now let's see how do I control that? Because remember, dump to JSON is what? Is a virtual function. So virtual function will depending on what object it was created. So how do I actually, within a virtual function, I can override that runtime determination? I have to use this explicit class type. So if okay, let me just give you this. Let me compare this. If I actually get rid of this as a virtual function, this is also kind of advanced, just to let you know. What's the difference between these two? Assuming that object was created as a locatable. What's the difference between these two? It's a huge difference. If you do the top, which is this to the MT3 thing, colon dump to JSON, it will directly call the base class dump to JSON. But if you call this to the dump JSON, it will actually call the locatable, which is the class you actually created for. Remember, what's the virtual function? Is what is the class at the time the object was created. So can somebody guess if you do the second way, what will happen to your program? You're going to have a segmentation fault or bus error because you keep calling yourself. And that's actually going to be recursive, infinite recursive. And then you'll wonder why your program crashed. That's the reason. Let's actually see this. Hold on for a moment. Let's actually try to run this program and see if you can see the difference, okay? Let me show you this. I remember I make a for dump or bus arrow consistently. Okay, I'm going to use, say, test labels GPS. Let's try to do this. Let's try to use this one. Let me take a look at this program, what this program is doing. So the label GPS, I create 3 label GPS. I create 3, not label GPS. I shouldn't call label GPS. I should call Got it wrong. I want to test NT3 thing, sorry. Okay, so I create a label GPS object over here called GPS TLC UC Davis. I create a person called Felix. And I create a holdable object called item one with this information. And then I have the MT3 things over here as a pointer. So I kind of casting the pointer of holdable to an MT3 thing. Okay. So now I'm going to do this. I'm going to just do dump to JSON. I will just do this 3 line. I'm actually here. And then I'm going to return. Okay, so you can see what I have is I create a holdable object, and I just dump the JSON of the value X, and I just print the X. By the way, I realized I don't need to do 2 style string in this library because it was very powerful. I can just do this. I can just print the JSON like this. I'm surprised. Wait a minute, it didn't compile test MT3 thing. What is the make file? Okay, make test MT3. Redefinition, okay, I will get rid of that. What is this? I already declared, I thought I didn't. Oh, okay. Fine. I'll just say XY. 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 Okay, I have the program. Now I try to run it. MT3. When I run the program, you can see that it has a 3 portion. One of the portion is the sequence number, which is MT3 dump to JSON. The second part is locatable.json, which has a locute, latitude, and the label. I use a label GPS. And then I have the holdable, which is with the res. Okay. I want to show you one thing. Let's show this thing first. So now I go to locatable dot, sorry, it should be locatable.cpp. This program, if I change this to this, does that make sense? Sure, I need to change the other one as well. Holdable. Okay, dump to JSON. I don't know which one it is I need to change, but I just change both places to make sure I got the core down I'm expecting. So I'm actually going to change this to remove this to be locatable. Okay. In fact, I don't think I need this. I think let's try, let me try this way first. Okay, if I run this program now, you see I got a segmentation fault. The reason I got segmentation fault is just keep running because it's a virtual function. It always tracks what is exactly class type this object was created. it will go back. So the way I roll the code over here will make a recursion because I try to call the my base version of dump to JSON without using a locatable column. If you do this to the dump to JSON, it will just keep calling yourself. And then which is going to cause, I think even if I do this is the same thing. If I do this, because I remember I actually removed the locatable from the locatable.cpp. If I do this, I think I'm still getting segmentation false. Yeah, still getting segmentation false. So you see that it's about the control about what function you want to call. In virtual function or in regular function, how do you do that? And that part of the code is just segmentation fault because it basically running out of memory. It's just recursion, and I run out the stack space over my operating system. Okay, so now let's actually go back to locatable. I hope this give you a good demonstration about what kind of mistake you should avoid, and then what you need to, I would say, arrow. Okay, I want you to, I just leave the code there so you can contrast the difference. Okay. So the first line is just basically printing. I want to invoke the parent version, which is in this case is MT3 thing, and his version of dump to JSON. And then the result will be saved on the result, the JSON object result. And then I will check whether the location is null or not, whether you have a valid location. If you have a valid location, I will just say result location, and then I will say location called dump to JSON. So essentially I have a dump to JSON for every single class I have in this directory. If you go to the master directory, you will see that almost every class has a dump to JSON. So because why? Because dumping is so universal, and the object is a composite object. It contains other object. For example, in this case, I contain another object called GPS, and it will actually give me that location. And by the way, this is even more interesting. Let me see, what is the type of the location? Anybody remember the data type of the location? Locatable. You see that? This location, the attribute under locatable is a GPS, right? It's a GPS DD. But when it was printed as a locatable because GPS is the base class for label GPS. Okay, so let me actually tell you. Let's remember this. So this is another example of virtual function that's actually being so useful here. So I have an attribute in locatable called GPSDD. And then within the dump to JSON of locatable, I set this location to the dump to JSON. If you look at this line and that line, you're expecting this dump to JSON is going to call the traditional GPSDD, which only have two attributes, which is longitude and latitude. But because dump to JSON is a virtual function, it will look at what was that location pointer is pointing to at the time of a creation of the object that it's pointing to. Because that object happened to be the label GPS. So it will, when you call this location dump to JSON, it's actually going to call the version of dump to JSON under label GPS. Let me go back to the code. If you remember, MT3 thing we just did. Look at this, what I did here. I actually create a label GPS called GPS. So it's a label GPS with a label teaching and learning complex. But when I save the location, you see that this location is what? It's GPS DD. It's GPS, is not labeled GPS, but I saved the pointer to a labeled GPS to a GPS. Okay, so the relationship between labeled GPS and GPS is GPS DD is a base class. Labeled GPS is a derived class. So I'm actually casting into a pointer that's saving the location, which is a GPS DD. But doesn't matter because it matters is at the time the object was created, what's the type? And where is when was it created? It was created over here. That was the time this object was created. And that object was created as the type labeled GPS. So when you call the dump to JSON, it will actually call the correct. So let me just try to run this program again to make sure you see the difference. You can see that when you print the location, they actually print not just the latitude, longitude, but they also print the teaching. But if I do this, okay, if I go back here, go to locatable. Sorry, I don't want to go to locatable. If I do this, I said GPS DD. If I do this, it will override the virtual function. It will force it to the GPS. So let's try to see if I do this, what kind of things it will happen. You see this time, the location is gone. It's only have latitude and longitude, it doesn't have the label because I kind of force it to execute a particular version of that virtual function. Okay, let me better change it back. Take this thing here, force it. But the correct way should be this, because that's the design of the dump to JSON. I want to be a virtual function. I mean, I don't care how you casting the pointer or casting the object, but I know with a virtual function, it will always remember what is the object, what is the class it was created initially at runtime. And therefore, I will base on that to decide which version to call. So there's, if you don't understand anything, I want you to remember two things. One is, what is the mechanism of the virtual function is to help you to determine that which function to call. The second thing is, want you to remember is that virtual function cannot be handled by compiler. So the determination about what exactly the member function, the virtual member function I'm going to call is actually need to resolve at runtime. I will tell you more detail about how it resolves at runtime, but at least I want to know as a programmer, especially computer science major, there is a difference between the runtime and compiler time in a language, programming language like a C++. Okay, it's a very, very interesting difference. Okay, any question? Okay, let's continue. So this is, I hope you understand this 5 or 6 lines of code. It will print out both the base class MT3 thing with the dump to JSON, and then it has a location. Okay, let's actually go to another derive, which is the holdable. Okay, again, holdable. Let's look at the holdable, the definition. So holdable definition, it is inheriting from locatable. It has one attribute called person. So it's a pointer to a person called holder. and it has a virtual function called dump to JSON. Okay, so now let's actually take a look at how is let's look at how it's implemented. So again, the first line is that, well, I'm actually going to print the dump to JSON from my immediate direct class. Immediate, not all the direct class, immediate, because my immediate direct class will recursively call the dump to JSON to whatever his base class was. So that's why the first one you see that I'm actually calling this. Again, I use the same trick, locatable column, which will force it to call my immediate parent. Okay. And then I'm actually checking the holder is a result holder. Okay. And then you see that I said this holder dump to JSON because holder is what? Is a person. And the person also have a dump to JSON. Okay, so now you can see I basically recursively, I can dump everything. Now I have to go back. Remember, we talked about the example of a person class, which could be derived class of a student and whatever, right? So depending on how was this person object created, whether it's created as a person, as a teacher, as a staff, or as a student, when you make this virtual function call, it's going to call whatever version it was created at runtime. So if this object, the holder part, was created as a student, so this dump to JSON is going to call the student version of the dump to JSON. If it's just really created as a person, then yeah, it will create it. Okay, so you can see that the virtual function, if you only take a look at the code, you actually don't know exactly which function it will be calling. Because in this example, I actually don't even know. I only know this holder is a person pointer. It's a pointer to a person. So I don't know whether that particular person object was created as a person or as a student or as an employee or as whatever. And that is totally undetermined. If you look at only this piece of code, the compiler actually have no information. So now you actually start to see that why it's difficult for compiling. If I actually write the piece of code looks like this, the compiler has no information about student. The only thing it has is about person because that's the data type of the person holder. I only need to tell the compiler that this holder is a person class. So I can get this part of the code compiled. But exactly whether it's a person or it's a staff or it's a teacher is totally resolved at runtime. So that's interesting. Okay, that's interesting because traditional C or Java programmer, you don't have this kind of mechanism. You just rely on compiler already done a lot of things for you. But now we have a polymorphism, which is essentially the code you're executing is dynamically linking. Dynamically linked to the code, and it will only be resolved at runtime. So that makes this concept interesting, powerful, but sometimes very difficult to understand. Okay. Any question? I think I go through this first iteration of an introduction to holder. By the way, you can take a look at this code. Let me tell you where to find it. Yeah, no, don't worry. I'm going to send it to the how do I say that? I'm going to send it to campus so you can actually take a look at them. Okay. Any question? Okay, just quick announcement as I saw as I talked about this earlier. I'm sick, so don't come too close to me. That's why I'm wearing mouse mask. Number two, today's office hour will be online via Zoom. Okay, I don't want I have any close contact with any one of you. Okay. All right. Enjoy and be safe, be healthy. All right.